Hello everybody, I have a pre-announcement for you today from the CSM folks, so I will let them talk. Here you go. Go for it.
Hi everyone, my name is Prisha. I am one of the coordinators for 61B through CSM. I'm here with Robert.
Hi everyone, my name is Robert. I'm the other course coordinator for CSM 61B.
And we're here to just give you guys an update on some of our sections that we have open right now. So I know you guys have a midterm coming up in about a week and a half, and a great way to prepare for that is through going to just general discussion and using other course resources. But CSM also provides week-to-week sections for free tutoring, basically, in small group discussion sections. The purpose of our organization is to provide mentorship to students in UC Berkeley in the lower level CS classes. And we have sections open right now on our scheduler, and if you're a student enrolled in 61B and you're interested in getting some small group support, you can go online and sign into scheduler.csmentors.org. We also have flyers and dum-dums, and we're gonna, as we're leaving, if you guys want one, feel free to raise your hand and we'll come and hand it to you. But yeah, that's what our organization's about, and we have some sections still open right now that are available for signups.
Great, thank you. Thank you so much. All right, so if you want free stuff, get it.
You also get a lollipop.
Okay. All right, I think we're ready. Okay, hi everybody. Okay, so we're talking about some more Java stuff today. We're almost done with, I think of it as our Java crash course at the beginning of the class. We'll have one lecture left that's in this segment that's Java related, and we'll have a few more later on. So I'm going to start by talking about the goal of today, which is to build an array-based set. And I'm going to do the really boring stuff already. It's already done, and we're going to do the newer, cooler stuff. So I'm going to start by explaining what the goal is. So we're going to try and build an array set, and there's not going to be any interface. So the thing we did last time where we have a set interface and then in some class that implements the interface, that's not part of our deal today. And what we're going to do is, the idea of an array set is it should work like this. I can add cities like Oakland, Toronto, Minneapolis, Oakland, Taipei, and here this add has no effect. Why? Yeah? No? That was a flyer. You wanted a flyer. Why is this adding of Oakland do nothing? There's already Oakland in the set, so it's not allowed to have duplicates. Also, are we the right amount of moodiness and lighting? Good. All right. And that's just like what you've seen already in Python before. All right? So we want to build this array set, and I'm actually going to start with some of it already done. So I'm going to start from the point where add is implemented. That's the thing that adds it to the set. That contains is implemented, and there's a size method. And for now, I'm just going to ignore resizing, because it's not the main point of the day. So I'm going to just show you roughly what the set looks like. In an array set, I still have a backing array like we had with linked list arrays or linked list decks, where I have an array in this case of 100 objects. That's going to be our core data structure. And what contains is going to do is it's just going to step through that entire array and see if it's there, and add is going to check if it's there, and if not, add it. And notice that add, it's important that it checks if it's there first, because you don't want duplicate copies. Okay? What does contains look like? Okay, so it's not going to be a big deal. I'm just having it on the slide again because it's like you've already seen this kind of pattern many times. I'm going to say for each item in the array, is that item equal to x? And I'm using dot equals here instead of the equals operator. And I'll review and talk about what the distinction is between dot equals and equals is here. You may know that equals and equals just compares the addresses. Like that's what it does. It says, are the bits the same? But we'll like reinforce that in a little bit. And then add looks like this. If the set does not have x, then we check first, does it have x? If not, we add it. And you can, if you want, you might say, what about, like, what if someone tries to add null to the set? You could have an illegal argument exception if you don't want null. In my case, my set's allowed to have null. Okay? Although it can get a little messy, but this is just, I just want to get like the basic framework down and not worry about nulls today. Okay? Any questions about the basic setup? We have an array set. You can add to it. You can contains it. Okay, so what are we going to do today if we've already done all that stuff? Well, what I'm going to show you is how we can iterate over a set in Java and how we can make our set iterable. So Java allows us to iterate over lists or sets using this convenient shorthand syntax, which is sometimes called the enhanced for loop or the for each loop. You might have seen this before. So given a set of integers where I add 5, 23, and 42, what this code does is it will print what first? Do you think? I mean, there's no guarantee, I guess, based on what I wrote here. But what do you think might get printed first? 5 maybe, and then 23 maybe, and then 42. That's what I might expect to happen, although there's no actual guarantee of what order they come out of the set in Java. Okay? So the way this works, this for each loop, is you can think of it as I repeatedly gets reincarnated as each element of the set. First it's some number, then another, then another. Okay? If we try and do that with our set that we had starting this lecture, it's not going to work. In fact, I'll go into IntelliJ and show you this fact. So here is the array set. And if in main, I say, iterate over this set, it doesn't know what that means. It yells at me and it says, I don't know. And that makes sense because how would Java know? It doesn't know like how to access the elements of this set. It doesn't know the semantics that we have this array that represents its items. It doesn't know about the size variable, so it won't work, right? It doesn't know how colon is defined, so to speak. Okay? So we want to make that work. That's our goal. We want this code to compile and run and print out all items in the set. Okay? So that's our goal. Any questions about our goal? Yeah.
What chapters does this correspond to?
This should be, hopefully, the ones that it's linked to. And if it's not, I'll fix it. So, yeah. It's in there. The question was what chapter in the textbook. It's possible the link's slightly wrong. But it's the one about iteration. Yeah. Okay. So I need to tell you how iteration works in Java. Like how does the for each loop work for normal sets? Like if I do an actual set, this will work fine. What's actually happening there? Okay. So it turns out, and we're going to spend 20 minutes digesting this, but this is the one slide summary that's hard to fully digest. This enhanced for loop, it works with a real set by first calling the dot iterator method of the object, and that returns an iterator, which is a new type we've never talked about, over integers. And then the iterator you get back, it is another interface that has its own pair of functions. It has next, which tells us whether there are more values, and next, which gives us the next value. Now again, I don't expect that most of you understand what's on this slide, but by the end of the lecture, I hope you can look back at this and say, ah, okay. So here, when we try and call this for int I and a set, something here breaks. So what's missing here? What do you think? It doesn't have this iterator method that returns it. Like if I go to my array set class and I control F iterator, it does not appear, right? That's not there. There is no iterator method, so it's not going to work. Okay. So that's the nice version of iteration. But I'm going to tell you a secret, which is that this nice iteration is actually something else in disguise, which is what I'll call ugly iteration. So when you write this code in Java, so you can do this in Java. You can iterate over a Java set just like that. What is actually happening is the code is secretly getting translated into the following code. Hey, iterator, you're called seer, or whatever, it doesn't matter what the variable name is. Go get an iterator from the set. And then as long as there's more stuff to get the next thing and print it out. Okay? So even though you don't see an iterator getting instantiated, you don't see a hasNext function call, you don't see next function calls, this code right here is just shorthand for the code on the left. Okay, so in other words, you write this code, this is what actually runs. Okay? So both of those pieces of code are exactly equivalent. Any questions about this? Yeah. So hasNext is something that any iterator needs to have. That's the idea, yeah. So iterators, we'll see the definition of it later, but it has to have two functions, hasNext and next. Other questions about this? Which one do you like better if you had to iterate over something? That one, yeah, this one's much nicer. So this is shorthand, so you don't have to write that code all the time. Okay? All right, so how do we do it? Well, let's think about what the iterator actually does. So in the Java set, what actually occurs is when we instantiate the iterator, which I called seer, okay, you can be in the corner of that thing. When I run this code, I call this guy the seer. It appears, and when I say iterator seer equals Java set iterator, this wizardly looking character appears and is sitting next to the 5. Okay? Then we ask it, is there something left? And the wizard says, yeah, true, there is something left. And then what does it do? Well, then we're going to call seer.next. And what's interesting about the next function is it actually has two jobs. One of those jobs is to return the 5. And what's the other thing that it does? Moves forward. So next, it has a side effect of advancing the iterator. And it also gives back its value. So the wizard yells 5 and takes a step forward. Okay, so after we've done that, we print out 5. And the wizard's now sitting there. What happens next? We go back up to this line. So what is the wizard going to say next? True, right, it's true. I do have more stuff. So then he'll step forward and say 23. Do you still have more? True. Step forward and say 42. Wizard, do you still have stuff? False. Okay, that's exactly how an iterator behaves. And when you write your iterator class, that's what it should be doing. Okay? Any questions about this? That's conceptually what an iterator is all about. Okay. Is this like a concept that feels comfortable from Data 88 or 61A? Yeah? Okay. To some degree. All right. So let's try and actually do that for an array set. Okay? So I'm not ready for this yet. I'm going to come back to that. I'm going to start by, oopsie. I'm going to start by going in here, and I'm going to write some code. So we have ugly, I want the code to work with ugly iteration. That's going to be my goal for now. Oops, there we go. Okay, so let's imagine we want the ugly version iteration to work. So I'm going to say iterator integer equals aset.iterator while, and we'll call it seer. Okay, so seer, and we'll say while seer.hasNext, we will do system.out, or no, we'll say, yeah, system.out.println seer.next. Okay, that's just basically what we had before. And we have a problem here, which is that the array set does not have an iterator. Okay, so let's go make one. So I need to do public iterator integer. That's the thing I'm supposed to give back, right? That's what it says. And it's not called getSeer, it's called getIterators, or just called iterator rather. And that's the function I need to declare. Okay. One issue is that I need to import iterator. So I've imported Java util iterator, and now we're closer. And what else is it yelling about? Okay, nothing. All right, so public iterator integer iterator, and I return null for now. Okay, so that code will compile, and this code compiles. Everything's looking pretty good, except of course right now when I run it, it's going to crash because it's going to say null.hasNext. So I need to return an iterator. Okay, good. Wait, but how do I do that? What is an iterator? Well, we know it's a class that has both what methods? Yeah, we need to return some sort of object that has a hasNext function and a next function. Okay? Well, we don't want to return this. Like, that doesn't work because what is this? It's an array set. It needs to be something else. It needs to have hasNext and next. What can we do? Suggestions? Yeah? Make a new class that's inside, okay, which I'll call it, I don't know, wizard iterator or something. Public class wizard iterator, okay? It's not a good name, but it fits our picture. Oops. Public class wizard iterator. No, we can make it private. That's fine. Let's make it private. I like that better. And what does it need to be? What kind of thing? It's not just any old class. We have to say it's an iterator, as you said. Okay. And we're going to be returning one of these things. Okay, well, this yells at us and it says, well, if you're going to be an iterator, you're going to have two functions. So I'm going to say implement methods, like you've seen on the projects. And I'm going to get these two methods here that I need to fill in, that I need to override. Getting closer. And then here, instead of null, I'm going to do what? New wizard iterator. That's going to be important. But still, the wizard iterator doesn't do anything. Okay, so still, it's like we're peeling back layers of boilerplate code. So let me just reiterate before we fill it in. In order to run this code, we need to be able to get back an iterator using an iterator function. So we added that function. But then we needed to make a class, and that class had to implement iterator. Okay? It is actually quite straightforward, but it's just like many layers of indirection. And this is one of the reasons that people find Java annoying, is because it has this bureaucracy to it. But once you understand it, it's really nice because it makes it harder to mess things up. You don't accidentally return an array set instead of an iterator because it's just structurally impossible to do so. Okay, so we're not done. So wizard iterators, we need these functions to do something. And it's kind of weird. It's like, okay, when the wizard iterator is first built, it just always says there's nothing. But it really needs to be thinking about whether or not it has given back all of the items and items. Okay? So my wizard iterator, it needs to somehow have it needs to know where it is. A wizard needs to know its own position, as you guys know from wizard school. Okay? How would the wizard know where it is? This is a classic question. Should be on the entrance exam to Berkeley. How does a wizard know where it is? In that kind of voice. Okay? Yeah? Give it a variable, right? That's how you give it properties. Private int, I'll call it wizard position. Then I'll make a constructor for wizard iterators, and we'll say, when a wizard is born, where is he born? What do you think? 0, right? That's where he's going to start. And then, whenever we check and say, does the wizard have more stuff? What are we going to check? I'll get lazy with you guys. Like you guys like to write code. Okay, if. Something to do with the wizard position, right? If wizard position is what? Less than size. Yeah, that sounds about right. Then we'll return true. Now, I'll know it's actually even better to say wizard position is less than size. You don't need the if statement. This is just, I don't need that parentheses. So that's the nicer way to do it. Pro tip. And then when we do next, what do? We're supposed to get back an integer, so I'll say int thing to return equals what? You could do get, but there's no get function in a set. It's just going to be items. I mean, you don't know the class well, but I'm just going to get the items wizard position. So wherever the wizard is, you're going to get that current item. You're going to say thing to return equal items wiz position. Something's a little funky here. We're going to figure out in a sec. Then I'm going to do wizard position plus equals 1. And then we're going to return thing to return. Okay, so we're pretty close, although it's mad at me about what? Required type int provided t. Items wizard position. Yeah, it is an array of general. Oh, right, because it's not necessarily an integer. It's going to be all right, I messed everything up, but now we can fix it. This should really be a t. Okay, and now what's wrong? Should be a t. Okay, we're getting closer, but now it's confused about t. Okay, this is interesting. I never had this problem. Oh, and it's supposed to implement iterator of t. Okay, so there we go. We were getting not generic enough. And then here, this should be iterator over t. And now everything's fine. Okay, I don't know why I decided it should be integers. Okay. Yeah.
So in the main class,
Yeah.
where you have iterator integer,
Yep.
does that mean that the return values, like the values inside of asset have to be integers?
Yeah, instead of, so the question was, isn't this returning integers, not int, right? Is that your question?
Oh, no.
Oh.
It only works with integers, not other data types?
Oh, this only works with integers because the array set's of integers. But if I were to change this to string, then I would just change this to string. Yeah, I don't know why I was just very integer brained there, but really The T's everywhere else make it so that I can put anything here so long as they match. Okay, let's try running it. Okay, here it goes. It ran, and the numbers printed out. Okay, let's actually go and look at it in the debugger, though, real quickly to convince ourselves that wizards are real. Okay, this is an important lesson in college. If you ever are wandering campus at night, and a small gentleman, for example, is cavorting under like a mushroom, talk to them. That's my other piece of advice. All right, there's the wizard's position. And then as we go forwards, as we step forwards, we'll see that the wizard will repeatedly increment its position. You don't get to see him there because it's just the integer, but that's what happened. Okay? Make sense? Everybody happy with that? Okay. All right. Question for you. Will the pretty iteration work? Well, it turns out it won't. Okay, it says it won't work yet. I'm going to uncomment this. And I'm going to say, even though this code works up here. So this was the ugly iteration, the one that I said doesn't seem as nice to use. It works. This one is not working. It will not work yet. So I want you to think about why that is. Okay? I told you that this code on the left is just shorthand for the code on the right. And as an annoying question to ask you, what does the compiler need to do in order not to make a red squiggly? Why is it mad? What things is it checking in order to make everything compile? And I'll let you think about this for, I don't know, a minute or so. Good luck. This is a slightly mean question, but only slightly so. And this is not lecture 11, it's lecture 9. Whoopsie. I renamed it in one part, but not the other. Okay, there we go. Yes. I don't remember how it's set up. Oh, no, it's not a trick question. Okay. I thought it was a trick question. I just haven't asked it in so long. But it's not a trick question at all.
It's multi-select.
Right, yeah. Yeah. You got it. Okay. I have some responses. So many of you believe that it is A and D, and I absolutely agree. Okay. So the idea is, first, the code, in order to check this, it's just running this code. So first it's going to check, does this right here, this set object, does it have an iterator method? Yeah, it does. That's good. And then when it gets this line, it checks and says, oh, does the iterator interface have a next and a has next method? Okay. Those are the two things it needs. All right. So it's a little bit indirect. Like I know that when you first learn this stuff, the distinction between an iterator and what we'll learn in a sec is a little fuzzy, but this is an important slide. If you get this, you understand kind of like the way that all the plumbing connects between our classes. So how do we support ugly iteration? What do we have to do? Well, we had to add an iterator method to array set that returned an iterator. And that iterator needs to have a useful has next and next method, as we just did. That's the thing we had to do. That's the ugly version of iteration. Okay? And once we were done, it looked a little something like this. This is what we built. This is just the slide version of the same. Okay? All right. So we need one more thing in order to support nice iteration. As we just saw, Java is not smart enough to realize that there exists an iterator method. I mean, it's there, right? I mean, there is indeed an iterator method, but Java is not smart enough to say, oh, someone's trying to iterate over it, right? In another language, or Java could have been designed differently so that if an iterator method exists, so I'll make that very clear, Java could have been designed such that if an iterator method exists, then :aset works fine, because it would realize, hey, this method exists. But that's not how type checking works in Java. Okay, fine. type checking in Java is very formal, and we have to explicitly state hyponym relationships using implements and later extends. Okay, we haven't learned that keyword yet, okay? You can't just rely on the fact that it exists. You need to explicitly say that this array set has this function. It's not enough that it exists. You have to say it has it. So one way Java could be, I could say like, hey, or like, has iterator or something. Like that could be the syntax in Java, maybe. Like I would say it on like a function level. But instead, what I need to do is say that an array set implements some interface that has iterator in it. Okay, does it make sense? Like that's how we usually do it. How do you say what you have? You say what you implement. So if you implement list61B, what is, if you implement deck61B, what's a function you have to implement? Remove first, remove last, all that, you know they're there. So it turns out there is an interface in Java that says you have an iterator method. You want to guess what it's called?
Iterator.
Nope, it's not iterator, because iterator has next and has next. Iterable. So if I say iterable, the iterable interface is very simple. All it is a method that's called iterator. Let's go look at it real quick. Iterable interface, Java, okay. So the iterable interface in Java is mostly simple. The main method it has is iterator, okay? That's the one it has. That's all. There's actually two other functions there. One's called for each, which takes consumer $super T action. But good news, that one's default. I don't know what the hell that thing is. I mean, I do, but you have no idea. And I actually have no idea what this one is, though. These two functions you don't need to worry about. You just need to provide this iterator. Where does this method for each come from? It's in the iterable code. So if you want it, and I probably shouldn't do this, but let's look up iterable GitHub Java JDK. Okay, let's see if we can find it quickly. No, that's not it. Here we go. Android ADK, Open JDK. Thank you. I'll see if I can find it quickly. It feels like a good idea. It's not. Okay, never mind. I can't find it quickly. There is a link in. I don't think there's one from here. No, the docs don't link to the GitHub for Java. But you can go look at it, and I'm sure it's some monstrous, horrible thing. We don't need to know about it. It's below the level of abstraction. We're the monks. Oh, sorry. We're the people in the cave, and the monks who work at Oracle. They're the ones who wrote this for us. Okay. Point being, though, this iterable interface, it declares that I have a method called iterator. And so once I do that, now that I've done this, now that I said I have an iterator function, this will work just fine. If we go down here, we can delete our ugly version. And it will work, hopefully. Did it work? It worked. 5:23:42. Now, we couldn't follow the wizard as he walked, which we always want to do, right? Follow the wizard when he walks. That's like an activation phrase. Like one of you guys is going to do something you were trained to do by the CA some time ago. Follow the wizard when he walks. We can't do that here. It just happens. We can't see the wizard's position, but it does exist. Yeah.
Why did you, when you implemented Iterable, why did you only have an Iterable class with the array set and not the other two methods that were in the
So when I implemented Iterable, to implement Iterable, all I need to do is have iterator. That's the only function that you need in order to be iterable. So I say, are you iterable? And you say, yeah, I have an iterator function. Okay, yeah? Oh, right. I had these other two. And the reason is they're default. Yeah, that's why I didn't have to write split iterator, and I didn't have to write for each.
What does default?
Oh, default is something from the previous lecture, which was a method that the interface actually implements. So we had the example of printing a deck.
So it's like the class that implements the Iterable class?
Yes, the iterable code, it does something with this iterator function to like fill in a default choice for this.
So our array set just kind of inherits?
Yeah, our array set inherits that implementation. So there's implementation inheritance here that we don't have to worry about these things. And this is a good example of implementation inheritance because you don't want to write this thing probably. Yeah. And a lot of this has to do with, you might have noticed we never talked about list comprehensions in Java. They do kind of exist, and maybe we'll talk about them later. And this has to do with in Java 8 how those were introduced to the language, which is tricky given the complex type system of Java. So this is kind of stuff like, it feels a little hacked into the language and hidden behind the default keyword. Okay. But that's a little beyond the scope of our class. Okay. So we did it. All right. So basically, here's the picture version, if you're getting a little lost in the talking. To support an enhanced for loop, we have to say that an array set is iterable. Okay? And what does it mean to be iterable? It means you have an iterator method. So by saying array set implements iterable, the compiler knows that array sets have this function. And again, that may seem silly to you. Why would I need to implement a specific interface just to declare that I have a single function? Isn't the compiler smart enough to open my arrayset.java file and parse it and look to see the iterators there? Sure, but that's not how the whole situation's set up. Right? It has to do with the way that Java gets compiled into class files. I don't want to get into this, but the idea is this is the way we declare. We have to do the formal specification that we are an iterable. Okay? And then the second part, or this idea extends even beyond what we just did now. So for example, in Java, the real set interface, if you look at it, a set extends collection. Now I haven't told you what extends is, but basically if an interface extends another interface, it means that it is a sub-interface. So we don't use the word implements because implements mean something. It means taking something abstract and making it real. You're implementing it. Extends is like, I have something kind of vague called an iterable, and a collection is a more specific thing, and a set is a yet more specific thing than a collection. Okay? All right. Iterable. I have a link. Here's the old one. This is JDK11. Okay. Oh, this is what for each looks like. Okay, objects require non-null. I don't know what that means. And split iterator. Okay, so that's there. The hidden glue. Speaking of the hidden glue, so I don't use glue traps because they seem inhumane, but rat update. I haven't seen the rat for 3 days. I have a video clip, which I'll open now. This is the rat's last known coordinates. Rat wall. Okay. So I set up OpenCV to process some video files. Well, because I wanted to find when the rat was running around. Because here we go. Ready? Watch this rat. Hold on. Oh wait, he froze. There he goes. Into the what? Look at that. You got to talk to the wizards. That's what I'm telling you. This is freaky. Okay. So this is called a toe kick. Anybody a carpentry expert? No? Carpentry's cool. Anyway, this is a toe kick, and there's a little gap in the toe kick, like the ceiling of it, and there's a little secret space that I am too large to fit into. But if you go in here, there's some labyrinth, because the rat went in there, and I haven't seen it come out. So that's the rat update. Okay. Some other time, we could talk more about the rat. Maybe I could bring the rat to class when he's caught, and then one of you can adopt the rat. That would be really nice. Okay, anyway. So to support the enhanced for loop, these are the things I need to tell you. If you want to do it, if you want to build your own class, like for example, ArrayDex61B, you'll need an iterator method in your class that returns an iterator. What's an iterator? It's your own custom class. In my case, it was wizard iterator, and it needs to have a hasNext and next method. And then I need implements iterable when you define the class so that Java knows that iterators exist. Okay? And that'll be at the end of the I was sleepy when I wrote that. I was doing rat. Okay. And the last 2 tasks of project 2. Okay. Cool. Almost there. Last night. Okay. One quick note that's a little quirky in Java. You'll maybe notice this funny thing where I might do like int I equals asir.next. And technically, this function is returning a capital I integer. I do want to acknowledge just briefly, just to head you off on this certain thing that students do sometimes. It's not a good idea. But to set this up, I want to note that it is possible to do the following. If I declare a capital I integer and set 1 equal to it, and then I say little I equals I, it works. And if I do little I equals 3, and oops, okay, again, this is me working late at night, last night. We don't care about colors. That's fine. I'll make this bigger. Actually, we do care about colors. Okay, aesthetics are important. And, oh, no, oh, whatever. Okay, here's the code. All right, if I run this code, what happens after this first line is I get a memory box with 64 bits that points at the integer 1. That's like what an integer is. It's like a box which has a 1 in it. And then when I say I equals I, what happens is it automatically unboxes that 1. And likewise, if I have the number 3, which is actually 32 bits, and I say capital I equals lowercase I, then it will point at a 3. Okay, this is a lot really important. It's just a funny thing about Java. And again, Project Valhalla is going to fix this weird thing. And they've been working on it for a long time. And just beware this happens. What I want you to know is that while any of this stuff works, while you could technically put capital I integer here, like you could say capital integer I equals AC or .next and print it out just fine. Please don't do that. 99% of the time in this class, you want to use lowercase n. In fact, the only time you want to use capital I integer when you're using a variable is when you say array set integer. I mean, you might also use it for like integer dot whatever dot parse int or something. But integer, the main reason to do it is when you're picking a generic type. If you're writing code in this class that looks like, I'm going to write on the board, sorry, at webcast, integer I equals something, it's just like slightly wrong. It'll work, but it incurs like a small performance penalty. It's just bad style. Okay? That's called auto-boxing and unboxing, yes. Lowercase int is, capital I integer is not a primitive type. It's a wrapper type. And it's a class that only has a single variable that's a lowercase integer. Yeah. Okay. All right. Okay, we got a couple more things we need for project 2 at the very end, which is talking about toString and equals. So all classes, it turns out, are hyponyms of a class called object. We're going to talk about these two methods, toString and equals. We'll talk about hash code later. We'll never talk about the other ones. But every class, even if you define it yourself, dog or whatever, it has all these functions, and there are default implementations. And I don't want to say too much about it. But I do want to talk about writing a toString method. Okay. So toString is a lot like the underscore underscore stir or underscore underscore repr. Wow, I got lazy about Python. Is it REPR? Yeah, it's like those functions. There's just one in Java that gives you the string. And actually, if you look at the implementation of system.out.println object x, it actually calls x.toString. So if I print out my Java set right now, it is going to look a little weird. It's not going to give me what I want, and I want to make that better. So let's go down here, and let's implement ourselves a toString method. So if I say system.out.println a set, and I run this code, you've seen this before probably at some point. It prints out just like some weird thing. Well, Wait, why is it over here? Okay, I made 2 of them. I don't know how I did that. Okay, yeah, so that's what got printed out. Lecture 9, inheritance 2, array set, this thing. Okay, so we don't want that default. That's the default toString. Okay, so let's try and do better. So the default implementation is just the name of the class, which we just saw, then an @ sign, then the memory location of the object, but like what that means exactly is a little fuzzy. There's a lot of layers of virtualization between your code running and the actual hardware. 61C will talk about that to some degree. So let's write a toString method. Okay, this hopefully is fairly natural. So I'm going to say public string toString, and then I'm going to say override. I don't have to say override, but it's useful because if I do like toString, because I forgot to consult the wizard in the forest or whatever it was I told you to do, it will yell at you and say you made a typo, so I'll do toString. And if I now do like return hello, if I run this, what do you think it's going to print? Hello. Yeah. In that voice. There it is. Hello. Okay, we don't want hello. We want it to be something else. I could do, so what I'm going to do is something like string this stuff equals, this is a set, so I'll do a curly brace. Then I'll do, for t in this, I'm going to iterate over myself. I'm iterable. T in, why isn't that working? Not a statement. Oh, for tx in this, okay. So I'm going to iterate over all the things in this, and I'm going to say stuff plus equals x. And that will automatically call the toString method of whatever x is. It's another quirk about Java. So if x is like a horse or whatever, it knows to call toString when you add it to another string. And then I'm going to lastly do stuff plus equals closing braces. And I guess I'll add myself a comma space. And let's see, I think this will work. I'm not totally sure. Okay, we ran it, and we got, oh, missing return statement. Oh, yeah, right, that makes sense. Okay, return stuff. No, we don't need all this either. Okay, there we go. Okay, all right. Yeah, 52342. Okay, happy with that? Okay, yeah. If I said object X, it's a good question. I don't know what'll happen there. Maybe nothing. I don't know, you stumped me a little. Come to office hours, I'll think about it some more. I like T more, but X object apparently works. Okay, cool question. Yeah? We got this to work by saying that an array set implements iterable. Yeah, so now that we have the iteration, we can use it. One thing you'll notice is that Java or IntelliJ is yelling at me and it's saying string concatenation plus equals in loop. Okay, cool. I did that. Thank you for the warning. Well, the reason is it's slow. So I'm going to click this thing that says convert variable stuff from string to string builder. And this makes it much more efficient. And the code behaves exactly as before. It just now it creates an object called a string builder and uses an append function. Okay, let's talk about that a little bit. The reason this is slow is that strings are immutable in Java. So if I take a string and I add the letter A, it doesn't actually like combine them. It takes that string and creates a totally new string with A on the end. So why would that maybe be inefficient? Yeah, you might have a huge thing like the text of Moby Dick, and then you add like period. So now you're going to make a whole new string that's all of it. So this will actually run in a quadratic amount of time, not in a linear amount of time. Another thing is you'll notice that I'm just adding this thing right here. It might not be a string. It could be a dog or, I don't know, a list or an integer or whatever, but Java will automatically call to string on this object, which is nice. Python does not do that. For some reason, Python string concatenation does not just behave naturally. It's like the one thing that Java is a little more casual about. And then, yeah, that's how it goes. This is the string builder version. And if you want to know a little more, I have a little optional video, but I also just did it using IntelliJ. Okay. All right. Any questions about this? Yeah.
Can you remove the last comma space?
So you could hack it together with a weird loop. I think there is something kind of joiny, if you know the join command in Python, but I've kind of forgotten what it looks like in Java. So off the top of my head, I don't have the elegant solution. But you could like break out early, for example. Like the lazy way is like check here and say if we've hit the end already, we break or something. That'd be a lame way to do it. But there's a better way involving some kind of joiny thing, but I don't remember what it is off the top of my head. Yeah.
What's the point of having a toString method?
Great question. Why do you care about a toString method? Why do you care about a toString method?
Well, I mean, like from I kind of remember 61A.
Yeah.
Is this how we like represent
Yeah.
things?
I guess like, would you ever print out an array set? What do you think? Give me a circumstance where you might be printing an array set out.
If you like want to visualize everything.
You just want to see what's in there. Maybe you're debugging some code, or like it's some string you want to generate for the client. Like say you're running a website and you just want to display the whole set. So it's convenient. It's like often it's nice to see a string version of a thing. There's also another thing you can do, which I don't usually recommend, which is you can check if two things are equal by converting them into strings and seeing if the strings are equal. So that's sort of a poor man's equals implementation. Okay, good question. I love those motivation questions. All right, now let's talk about equals. This is the last thing we got today. So we wrote a toString method. Let's write an equals method. So the equals method takes in an object and it tells you, are you equal? So if I do, is my array set equal to 5? It'll be no. Right? Is an array set equal to another array set which has the same numbers in it? Hopefully, yes. Okay. So as I mentioned in an offhand manner previously, or I think Peyron did, equal equals and dot equals behave differently. And actually, I don't even remember if I had Peyron talk about this, but did you? Do you remember? No. Okay. So in an offhand manner meaning in a previous semester, equal equals and dot equals behave differently. Equal equals compares the bits. So it literally just says, are these the same address? And dot equals does some kind of semantic comparison. It calls a function and decides they're the same or not. So here, if I have Java set, which has 52342, and Java set 2, which has 52342, if I were to actually call are these equal equals with each other, it would say false because are these 64 bits the same as these? No, they're pointing at different things. Remember the arrow is basically a visual representation of those bits. Like there's actually 64 bits here. We can't see them, but I know they're different because they're not pointing at the same object. Does it make sense that this doesn't work? And this isn't really maybe what you expect. You might say, aren't those sets equal? But this is asking whether or not they are the same object. Okay? If you want to actually check if they're equals, we'll call dot equals. Okay? But where does dot equals come from? We have to actually write it. So you have to write your own dot equals method. And there is a default implementation of dot equals, which just uses equal equals. That's probably not what you want, because you might imagine that there's multiple array sets, like these, for example, that can be equals. By the way, if you want to check if arrays are equals, you also have this problem. Like if I have two arrays that both have 5, 6, and 7 in them, and they're both linked 3, equal equals will say false. But if you use arrays.equal, it'll say true. And if those arrays are actually of references, then you'll need to use arrays.deep equals to do comparison. This is a little beyond the scope of our class, but I'm just mentioning it in case it bites you later. Okay. All right. So what we're going to do is give you an example of how we can fix this issue. So if I go back to lecture 2, and we wrote this maxDog function back in the day, we had this notion that there's always a this variable. It says who I am. And what I want to do basically is try and write an equals method that if somebody gives me another array set, I can check and see if it's equal to me in some sense, like in a deep semantic sense. So if I'm an array set, does it have the same values in it as me? Okay? So this, remember, is just the address of the current object. That'll be important in a little bit. Okay? Now, naturally, I can use this to access my own instance variables or methods. Now, you'll notice I don't always. Like, you can say this dot size, but you don't have to. But there are some times when you really do have to use this. Like, for example, if I need to return myself, this is the only way to do it. Okay, this is a little bit of a digression. But just remember, two things I want you to think about is equal equals compares the bits, and this is just the address of myself. Okay. One other thing I guess I'll mention, because this doesn't really get covered so much in our class, is that unlike Python where you really have to use self, in Java, you don't have to use this, but there's one circumstance, you might have seen this before in this class, where if you name a variable to your constructor the same as one of your instance variables, you can say this.size equals size, and it will treat this.size as different than size. I don't know, if anybody have tried this in this class, where you like picked a constructor variable the same as an instance variable? So this is like, if you wanted to disambiguate, you can use this. Okay. Anyway, that's a little side story, but just figured I'd mention it today. To the main narrative, though, I want to talk about how equals works. So the default implementation for equals is simply the following. Return, is my address the same as the other thing? And that's not enough when we want to say two array sets might need to be deeply equals in some manner. Okay? So in other words, if I create these two array sets, and I say, are they equals, what will this code do right now? What will it print? False, because a set isn't the same address as a set 2. They're two different objects. Okay? So I have to tell you one more thing. Okay, maybe that little bit of digression was confusing, but the important thing we need to do to write an equals method, let's start trying to do it. I'm going to go public. Actually, I'm going to start going right now with this method. So I need to do equals. Okay, what type of input does equals take? Do you remember? I just said it a little bit ago. Object O. And I want to return a Boolean. And I want to say, are they the same? Okay, how do I do this? I have an object, and if I try to do something like o.items, like o.items 0, it yells at me, and it says what? I don't know what items is. Why doesn't it know? Yeah? O is an object. It could literally be anything. It could be, again, a goat, an integer, an array list, whatever. We don't know. So we can't do that. So we need some way to like check if O is an array set, and if it is, start comparing the things in that array set. That's what we need to do. Okay, that's going to be my goal. And the way I'm going to do that is with a new and very cool keyword that you have not learned in Java yet called instance of, that uses a programming idea known as pattern matching. It is mind-bending when you first use it, but it is super cool. So instance of does the following. If I say if O instance of dog a dog, it does the following. It says, is O a dog? Okay, is O an instance of dog? Okay, let's say it is. Then, if the answer is yes, it returns true, and as a side effect, it puts the dog here that's inside O into a new variable that has type dog called a dog. Does that make sense? So it's like, oh, are you a dog? Yes, now you're a dog. Make sense? So, oh, you're a dog. Okay? And now I've done that, I don't put o.size here. Why can't I put o.size here? Because it's an object. We don't know if it's a dog. But a dog, we know it's a dog because we just checked it up here and like incarnated it. We like take the object and like squeeze it into dog shape. And then we can look inside of the dog. This is gross. When I was in biology, we had to dissect the animals. I didn't like it. Ugh. All right. Do you know? No, I'll tell you another story. I'll tell you about Descartes another time. Yeah.
Instead of using dog unadopt, you just had O instance of dog and then you cast the object.
You could cast, but I will not teach you in this casting in this class because it is old-fashioned. Yeah, but you could cast as well. So now that we know that, let's do it. If O, instance of what? Array set. Okay, what do we put here? Utter array set. Great. Okay, good. So utter array set. And then what do? Okay, so if it is an array set, then we want to check if it has the same stuff. So I'll say if this, well, I don't have to say this. I'll just say if size is equal to utter array set dot size. Actually, I'm going to do not equal to. Then what? So that we don't have the same number of things, so we're not the same, so we return false. Otherwise, we can iterate over all the stuff in ourself. Okay? And then we can check what? If the utter array set has it. Okay? If the other, so I basically take my first thing, I'm like, what? Okay, take out the thing. Do you have this? If the answer is no, then what? What do? Return false. Okay, if we get to this point in the code, we know the other array set is an array set. It has the same size. It has the same stuff. So we can return true. We don't have to worry about the fact that it has something that we don't because we're the same size. So if we're the same size and we have the same stuff, then we're done. Otherwise, we'll return false. We don't care about order, right? Yeah, for sets. Yeah.
Do we have to put the generics after array set, after instance of?
You do not, and I'll talk about that in just a moment. This is a sort of minor point of contention with the spec from project 2. Okay. So what we ended up with this, right? You just asked the question, did I need to say T? This is, you'll notice that IntelliJ is yelling at me and it's saying you have a raw type. I can't do this for reasons I can't really explain. If you really want, you could put a question mark there and the warning will go away. But I say don't bother. I mean, you could put it if you want. It's like, then you seem cool. But I'm going to leave it off, okay? All right, so you can add it if you don't like the warning. And there's like a slight difference, but again, one of those office hours things I'm happy to talk about later. Another thing I did on the slide but did not do live is I had if this equals other, return true. So actually I'm going to add it. If this equals other, return true. Translate this into English for me real quick. Yeah, if they're actually the same object, then of course we're the same. So that's basically an optimization that says don't look at everything in the other list. If we're the same object, we should be equal. Okay? So to summarize, we built our own array set, and now you know everything you need to know for project 2, even the last 2 tasks. I did ugly the nice iteration. Here were the little details. We added the string. We added equals. Here's the attendance link. Project 2's due Monday. You know everything you need. And today was the last in-scope lecture for the midterm. And I'll talk about the midterm and how to study next time.